So similar figures. Similar figures deal with proportions. Similar means they're not the same. They're not equal. They're not congruent. They're similar. They look the same, but one's bigger or one's smaller. Similar. It means that they're proportional. So first, let's begin by defining similar figures. Similar figures, by definition, have the same shape but not necessarily the same size. I mean, if they're exactly the same, sure, they're similar. They look alike. But similar figures most of the time are not going to be the same size. They're going to be the same shape. They look the same, but one's bigger and one's smaller. Similar figures have the same shape, but they're not necessarily the same size. And what this means is corresponding angles are equal. So the top right angle and the top right angle, they're corresponding, they're in the same location, they're going to be equal. Corresponding angles are going to be equal. If the bottom left angle is 82, the bottom left angle is going to be 82 on the other one. Corresponding angles are equal. But their corresponding sides are proportional. If the right side is 5, the other one's right side is 10, because I multiplied by 2. If the top is 4, and I multiply by 3, the other top is 12. So we're going to draw some pictures. Here's a parallelogram. Now I'm going to label it A, B, C, D. And I'm going to draw another parallelogram. This one's bigger. And I'm going to label this one Q, R, S, T. If these are similar, angle A is equal to what? What's the exact same as angle A? What's its corresponding angle?
B. Or D.
Q. Because they're in the same location, in the same shape. Angle D is the same as angle what? T. They're exactly the same. Because they're in the same location in similar shapes. They're equal. If angle D was 72 degrees, what does that mean? Angle T is 72 degrees because they're equal, they're corresponding. But the corresponding sides are what's called proportional. So if this side is 8, and this side is 40, what did I multiply 8 by to get 40? 5. So that means I have to multiply this side by something to get 20. These two are going to be the same. These are proportional, and these are proportional. They're not equal, they're proportional. So remember, we've done this before. Let's take and make a fraction. So the steps to solve a similar figure, which is solve for the missing side. Solve a similar figure. What we're going to do today, we're going to be solving for a missing side. Step 1. Where's my pen? Right here. Set up a fraction, which is a proportion, for shape number 1. Set up a fraction or a proportion for shape number 1. I'm going to set up a fraction, which is also called a proportion, for shape number 2, right? A ratio. And 3, I'm going to solve for the variable. And there are 2 ways you can solve for the variable. You can use common sense, or you can do cross products. Common sense is going to be the easiest. So let's talk this through. What's my fraction? What's my proportion for the first shape? What's my fraction? What are my 2 values? 8 over x. Could you say x over 8? Yeah, I don't care. 8 over x equals, what's my proportion over here? If I start with 8, which is the top, I have to start with 40, which is the top. 40 over 20. I set up my fraction for shape 1, 8 over x. I set up my fraction for shape 2, 40 over 20. Now I solve for the variable. I can common sense it, or I can cross product. Common sense as I look. 8 times what equals 40? 5. So what times 5 equals 20? 4. Or you can cross product. What's x times 40? I'm going to write it inside the shape because I don't have enough room. 40x equals, what's 8 times 20?
160.
160. Now what do I do? Divide by 40 What does x equal? 4. If I was going to put a label on this, it's 4 what? Units. Let's do another picture. M-N-O. X, Y, Z. And these are going to be similar shapes. However, it's rotated. So what angle is corresponding to angle O? Angle X. Good. So sometimes you have to do a little bit of rotating in your mind. All right, so let's solve this problem. This MN is 7 and ON is 4. This is X and this is 14.4 centimeters, centimeters, centimeters. And what if I also said, let's put a little more detail on this one. This one is 6 centimeters. And this one is Y. All right, let's first make a list of all of our proportions, our ratios. Right? If I want to know what X is, correct? I'm going to do X over what? 14.4. All right, let's now go to our other guy. What's proportional to X? Over here. X and 4. What's proportional to 14.4 over here? Turn it in your mind. 7. Can you common sense this? No. I can't common sense this, so I'm going to have to cross product. What's 4 times 14.4? 57.6. What's 7 times X? Am I done yet? Now what do you do? Divide by 7. X equals what? Round to the nearest hundredth, 2 decimals. 8.23 centimeters. All right, so how do I do Y? How do I solve for Y? I know what X is. X equals 8.23 centimeters. But how do I figure out y? We're going to have to do it again. Give me a proportion with y. Y over... Are you going to pick x? Nope. What? Y in the same guy. You could do 8.23, but I would pick this number because it's given to us. Tommy, please stop. So over here, what's congruent to y? 6 over, what's congruent to 14.4? 7. Can you common sense this problem? No, you're going to have to use cross products. What's 7 times y?
7y.
Equals, what's 6 times 14.4? 86.4. Am I done? Divide by 7. Give me 2 decimals. 12 point what? 34 centimeters. So sometimes you have to do 2 problems within a problem. Or you have to pick which one you're going to do. Which proportion you're going to make. But to solve a similar figure, you set up a fraction for the first shape. And you set up a fraction for the second shape. Then you solve for that variable. If you pick the short side to go on top, the short side needs to go on top. If you pick the top to go on top of your first fraction, the top goes on top of your second fraction. Drew, turn around. Similar figures. Set up the fraction, and solve.